And good afternoon, everybody. This is going to be your notes for graphing tangent and cotangent functions. It's going to be a little bit different than sine, cosine. So we've already talked about graphing sine, cosine, secant, and cosecant. It's going to be a little bit different than graphing these four functions. These four are kind of all related to each other, so you have either a sine wave or a cosine wave for whichever one you're graphing. So it could be a sine wave from 0 to 2 pi, or it could be a cosine wave from 0 to 2 pi. And then depending on whether it's secant or cosecant, then you would just put on your asymptotes. So if you had asymptotes for the sine wave, so let's say you're doing cosecant, so you're going to have an asymptote wherever sine is 0. So those are going to be your asymptotes. And then you have the reciprocal curves coming off of the sine and cosine. So this is for cosecant. And then similar thing for cosine, wherever cosine is 0. Here and here. Then its reciprocal secant is going to be undefined. So you're going to have asymptotes, and then you have your reciprocal curves going towards the asymptotes. So that's kind of a crash course in graphing those four. So sine, cosine, secant, and cosecant. So we've been studying those for a few days. Tangent and cotangent are going to be a little bit different as far as their fundamental cycle. One of the biggest differences is, first of all, the shape, and then also the period. So all four of these that we've studied, the period has been 2 pi. So the period for these, one cycle. So remember, the period is one cycle. The period has always been 2 pi. So if we had a b value in our equation, so if you were looking at the general sine equation, let's say y equals sine, whatever your b value is, x minus c plus d. If you had a b value, then to find your period was always 2 pi divided by the b value. One of the big differences for tangent and cotangent is the fundamental cycle length is not 2 pi. We're going to find when we make a couple graphs that the fundamental period for these two, one repetition, is going to be pi. So to find your period for these, it's going to be pi, the original fundamental cycle, divided by b. The general form is going to stay the same. So the general form for all 6 trig functions follows this form. Oops, I forgot the a value. So there'd be an a value right here. So the general form is going to be the same for all 6 trig functions. Where tangent and cotangent are going to be a little bit different is you've got to watch out for finding that period, because the first 4 have a period of 2 pi, and then tangent and cotangent only have a period of pi. And you'll see what I mean by that when we get into doing some of the graphs. So let's go ahead and look at the fundamental cycle, or the starting cycle, for tangent, and then we'll do cotangent. And just like when we first started to learning to graph sine and cosine, we did a input-output table. So let's do a quick input-output table for the tangent function. So if we have y equals tangent of x, remember this is the ratio, the tangent ratio after you evaluate it at a certain angle. So when you're making a graph of any trig function, you're technically plotting the x, which is the angle. So this is your angle scale, and then the y, which is the ratio. So you're just doing a picture of the angle versus the ratio. So let's look at some key points, and I'll just go ahead and give you which ones are kind of the good ones to look at. So for tangent, to look at the fundamental cycle between two asymptotes, you actually want to start in quadrant 4. We're going to do some points that are in quadrant 4, and then we're also going to do some angles that are in quadrant 1. So we'll start at negative pi over 2 for an angle, and then negative pi over 4, and then an angle of 0 radians, and then pi over 4, and pi over 2. And let's go ahead and find the ratios at these points, at these angles. So negative pi over 2, let's draw a unit circle. So let's make some room for this. So we'll do a unit circle. And we'll say we're going to have a radius of 1. So ordered pair is going to be 1, 0. This would be 0, 1. This would be negative 1 on the x, 0 on the y, 0 on the x, negative 1 on the y. And if we are at a rotation of negative pi over 2, then that's going to put us back here at this ordered pair on the circle. So your definition of tangent is the y value to the x value. So the y to the x, that's going to be negative 1 to 0. So if we think about negative 1 to 0, that's going to be undefined since we're trying to divide by 0. So this first output is going to be undefined. So the tangent ratio does not exist at negative pi over 2. It's undefined. And then let's go ahead and look at negative pi over 4. So this one's going to make a special 45, 45, 90. So if we make a quick picture of that, that's going to put you down here. If you rotate back negative pi over 4, that's going to be a 1, 1 radical 2. Negative on the y. And then if we do our y to x ratio, that's going to be negative 1 to 1, which is a final value of negative 1. So when your input is negative pi over 4, so if you input negative pi over 4, you're going to output a y value of negative 1. And then let's go ahead and do a rotation of 0. So we can go back to the bottom picture for this. So if we rotate 0, that's going to leave us right here. So your tangent ratio here at 0 is y to x. So 0 to 1, that's going to get you 0. 0 divided by 1 is 0. Pi over 4, that's going to put us into quadrant 1. So that's going to put us up here into quadrant 1 if we rotate pi over 4. And put on your values. That's going to be a 1, 1 radical 2. So y to x is 1 to 1, so that's going to get you 1. And then a rotation of positive pi over 2. Let's go back to the bottom picture. Positive pi over 2 is going to rotate to here. That's going to be positive pi over 2 for an angle. And if you look at your y to x ratio, that's going to be 1 to 0. So 1 to 0, which again is undefined because you're trying to divide by 0. So this is going to be undefined. So this is going to be one cycle between the asymptotes. So you're going to have an asymptote here, and you're going to have an asymptote here at positive pi over 2. So you're going to have two asymptotes for making this one cycle from negative pi over 2 to pi over 2. So those are going to be your asymptotes, and then you're going to have your curve. Your curve is made up out of these points in between. So let's go ahead and graph this on the graph. So here's our table of values from from the other page. So let's just go ahead and graph this table. So I already kind of set up the graph. So what makes a good scale is still kind of the traditional 8 boxes. You can go 4 to the left and 4 to the right. So we're going to have an asymptote at negative pi over 2. So you want to sketch in your asymptote at negative pi over 2. And you're going to have another asymptote at pi over 2. So that's where tangent is going to be undefined. And then plotting the 3 points in the middle. So the first point is going to be negative pi over 4 with an output of negative 1. So if it's 4 boxes to get back to negative pi over 2, then negative pi over 4 is going to be 2 boxes halfway there. So we're going to go back 2 and then down 1 on our scale, which is 2 boxes. And then the next one is at 0, 0. So that's going to put us there. And the next one is at pi over 4, comma 1. So 2 boxes over, 2 boxes up because I chose 2 boxes to be worth a value of 1. And then we're going to have a curve that goes through these 2 points and it curves towards the asymptotes. So that's going to be your tangent curve. And then this cycle would keep repeating itself. So the next one, the next set of asymptotes would be another 8 boxes over. So I'm not sure if there's enough room on the scale there. Guess that didn't come out very good. So the next set of asymptotes, 1, 2, 3, 4, 5, 6. Yep, just enough room. So you're going to have another asymptote there. And then tangent would be in the middle again, 1, 2, 1. And then it's going to go over 2, up 2, and back 2, down 2. So that would be your second repetition, or your second cycle. So this first one that we graphed right here, that is what we call the fundamental cycle of tangent. So it's going to start with that cycle, and then after that you're going to apply any A, B, C, or D values for transformations. And one question that the book is probably going to ask you is to write the equation of the asymptotes. So just like when you're doing secant and cosecant, you're just going to describe where all the asymptotes are. So they usually start with the first positive asymptote. So the first positive asymptote is at where x is pi over 2. So we could say x equals pi over 2 would be the first asymptote. And then how do you get from one asymptote to the next? You're just going to say plus multiples of the distance between each one. So from negative pi over 2 to pi over 2, that's going to be plus pi. And then from this one to this one, that's going to be plus pi. And they would keep going indefinitely, adding or subtracting a whole pi to get to the next asymptote. So it's going to be plus multiples of pi. So that would be your equation for your asymptotes. If you had a scale change, so if you had a period change, then this equation would change a little bit. But the idea is it's going to be x equals the first asymptote plus multiples of the distance between the asymptotes. And here's an example of graphing a tangent function that has a period change. So the general form, just like sine, cosine, secant, and cosecant, general form for a tangent function, y equals a tangent some b value x minus c plus d. And these values are going to have the same effect. This is going to change how fast it grows. So you can't technically call it an amplitude because it doesn't have a min and a max. It doesn't have a high point and a low point. But it is going to affect, how steep it is, so how fast it's growing. So this is going to affect the steepness. Or how fast it's growing. So whether it gets taller, faster, or slower. This is going to change the period. but the fundamental cycle is only pi long, so your period is going to be found by doing pi divided by the b value. So your period is going to be pi divided by b. The c value is still going to be the horizontal shift. So horizontal shift, so left or right. And your d value is still going to be the vertical shift. So this is still going to be the vertical shift. So really what you have to watch out for is your period change, and it's going to be pi divided by b. And that's a little messy. So there it is, a little bit cleaner. So pi divided by b is going to be how you find your period. So let's go ahead and do a graph. So here's our equation. We're going to try to graph y equals tangent of 2 times x. So 2 is the b value. So your period for this one is going to be pi divided by b. And b in this case is 2. So your period, your length of one cycle, is going to be pi over 2. So we'll set up our axes. And we'll still go 8 boxes, but remember the fundamental cycle of tangent, one asymptote was to the left of the y-axis and one asymptote was to the right. So we'll go 4 boxes to the left and 4 boxes to the right. And these are going to be our asymptotes. But if you recall from the parent function, this would have been negative pi over 2 to the left and pi over 2 to the right. So for the fundamental cycle, it would have been negative pi over 2 to the left, pi over 2 to the right, which gives you a period of pi. The distance between negative pi over 2 to pi over 2 is 1 whole pi. But remember, we have a period change, so we want the distance from asymptote to asymptote to be pi over 2, which means these are not going to be negative pi over 2 and pi over 2. So we're going to need to decide what those are going to be. And basically, to figure it out, you just want to go halfway to the left and halfway to the right. So halfway of a distance of pi over 2 is going to be pi over 4. So you're going to go pi over 4 to the left. So that's going to be pi over 4 this way. So negative pi over 4. And then you have to go pi over 4 to the right to get to the next asymptote. So these 4 boxes are going to represent pi over 4, so that you have a period length, a new period length of pi over 2. And then you can put in your asymptotes. So we have an asymptote here at positive pi over 4. And we have an asymptote here at negative pi over 4. And that's going to be our asymptotes, and then it's going to have the same basic curve. So if you choose 2 boxes on your vertical scale to represent 1, and then you're going to have your curve. So tangent goes halfway to the asymptote to the left, and then down 1 unit. So it's going to give us a point here, and then 0, 0, and then halfway to the asymptote and up to get us there. So those are going to be our points on the tangent curve. And once you have a graph, you should be able to answer some basic questions on it. So one of the common questions to really see if you have a good graph is to write the equation of the asymptotes. So in this case, where does our first asymptote start? The first positive asymptote, pi over 4. So we're going to have a vertical line at x equals pi over 4. Plus multiples of how far apart are the asymptotes. So to get to the next asymptote, they're 1 period away, so pi over 2, so plus multiples of pi over 2. So it's plus multiples of the period on this one. Secant and cosecant were plus multiples of half the period because there are two asymptotes for one cycle. So every asymptote is going to be pi over 2. So if we're at this one, we would have to go pi over 2 to get to this one. We'd have to go pi over 2. So 8 boxes to get to the next one. That's going to be plus pi over 2. If you kept going, you'd have to go another plus pi over 2. You could go backwards, minus pi over 2. So k would be -1. So you're starting at pi over 4, and then you're adding multiples of the distance between asymptotes. So that's going to be the equation of your asymptotes. They'll probably ask you for the period. The period you have to kind of do to make the graph anyways. So your period is going to be pi over 2. And you should have a clear enough graph so you could state some basic ordered pairs on this. So if you look at your scale, stating some basic ordered pairs. So if it's negative pi over 4 to the asymptote on the left, then halfway to pi over 4 is an eighth. So it's going to be negative pi over 8, comma -1 for a y value. 0, 0 for the center value at the origin, and then pi over 8, comma 1 for the other ordered pair. So that's kind of your 3 key points. And they might ask you for the range. The range, remember, is all the y values. So your y values are pretty much from -infinity to infinity. There's no breaks in the graph in the y value. So it goes all the way down to -infinity, keeps following that asymptote to -infinity, and then it keeps following the other blue asymptote on the right all the way up to positive infinity. So all your y values are going to range between -infinity and positive infinity. And let's go ahead and take a look at the cotangent function. And let's approach this the same way. Let's do a quick table of values since it's our first time, and then we will make the graph. And just like all the other equations we've been studying, you probably just are best to memorize the starting fundamental cycle after we get a good look at it. Memorize where it starts and then apply the A, B, C, and D transformational values after that. And let's just kind of quickly go through where the fundamental cycle is coming from cotangent. So we'll do the same thing. We'll choose some angle values. So that's going to be our x. So we'll choose some angles. And for this one, we're going to do angles between 0 and pi. And then we'll see what the y value, the corresponding ratio is for cotangent. So remember, this is your angle going into the function, and then this is your ratio coming out of the function. So if we look at the cotangent ratio, so if we have a rotation of 0, so that's going to put us right here. So remember, your cotangent ratio is the x coordinate divided by the y coordinate, so you're going to get 1 divided by 0, which is undefined. So that's going to be the asymptote, the starting asymptote for cotangent, since it's undefined. And then if you look at a rotation of pi over 4, then that's going to be a 45, 45, 90. So x to y would be the 1 to 1. So that's going to get you a ratio of 1. And then if you have a rotation of pi over 2, so if you rotate pi over 2, that's going to put you up to here. And if you look at your x to y, that's going to get you 0 to 1. And since the 0 is up top in the numerator, that's going to be 0. And then if you rotate 3 pi over 4, so into quadrant 2, So 3 pi over 4. And look at your x to y ratio. That's going to be negative 1 to 1, so negative 1. And then if you rotate all the way to pi, so if we keep rotating all the way to pi, and look at your cotangent ratio there, again it's the x coordinate, negative 1, to the y coordinate, 0, and that's going to be undefined again, so that's going to be your second stopping asymptote. So we're going to get asymptotes at 0 and pi, and then you're going to have your ordered pairs right here in between those asymptotes. And let's go back to the notes and graph our first fundamental cycle of cotangent. And looking at the table of values from the other page, let's go ahead and graph our cotangent cycle. So you're going to get your first asymptote at 0, x equals 0, which is the y-axis. So x equals 0. The other asymptote is going to be at pi. So these are the two first places where cotangent is undefined. And then plotting your points in between, so pi over 4. So if we choose 8 boxes to be pi, 1 cycle. 4 boxes is going to be halfway, pi over 2. So 2 boxes is going to be pi over 4. So you're going to go over 2 boxes and then choose your vertical scale. Let's make 2 boxes be worth 1 unit. So pi over 4, comma 1. And then you're going to have pi over 2, comma 0. And 3 pi over 4, comma negative 1. And those are going to be your 3 key points. And then you want to sketch a curve between those points approaching the asymptotes. So that should be your fundamental cotangent cycle. To write the equation of the asymptotes, the first asymptote is at x equals 0. And then how do you get from one asymptote to the next? You're going to have to add multiples of pi. So it's going to be x equals 0 plus multiples of the distance between the asymptotes, which is pi. And then you can simplify the 0. So 0 plus k pi would just be k pi. So the equation of the asymptotes are going to be x equals some multiple of the distance between the asymptotes, which for the fundamental cycle is pi. So x equals k pi. Your range for this function, all your y values are again from negative infinity to infinity. And your period is going to be pi. So cotangent's a little bit different than tangent. Two of the major differences are your asymptotes. Start out in different locations. Tangent, one asymptote was to the left of the y-axis, the other one was to the right of the y-axis. For cotangent, one's on the y-axis and then to the right of the y-axis at pi. And the other major difference is cotangent kind of curves or bends the other way. So cotangent kind of goes to the left and up and to the right and down, where if you remember tangent, a tangent curve goes to the left and down and then to the right and up. So they have a slightly different direction in their curve. And just to kind of recap the two fundamental cycles, one for tangent, one for cotangent. So tangent, the first one we did, so y equals tangent. It's going to have a period of pi for its fundamental cycle. Its period is going to be split, half of it to the left of the y-axis, half to the right. So it's going to go pi over 2 to the left and pi over 2 to the right. And then to put in the key points, one of them is going to be at the origin, so one will be here, and then you want to go halfway to the asymptote to the left, so back, pi over 4, and then down, negative 1, and then halfway to the asymptote and up. It's always going to be halfway to the asymptote off the center, and then it's either up or down, and that's going to get you your tangent curve. And for cotangent, Its period is also going to be pi, so it's going to have the same period. However, it's not going to start in the same locations. So instead of having an asymptote to the left and to the right of the y-axis, your first asymptote happens right on the y-axis, so at x equals 0. And then your next asymptote is at pi. So the period is still pi, it's just orientated or shifted to the right from a tangent cycle. And then your key point, you're going to have one key point at the center in between the asymptotes. So right here at pi over 2. And it bends a little bit differently, or it curves the other way than tangent, so it's going to go to the left halfway to the asymptote and then up 1. So if this is pi over 2, then it's going to go back to pi over 4 and then up 1 for a y value, and then it's going to go to the right pi over 4, so it's going to go to 3 pi over 4 and then down for a -1. So it's going to be your key points for the tangent curve. So those are your two fundamental cycles. So just like sine and cosine, you want to kind of memorize their starting locations, their starting points. So you want to memorize where they start, where the asymptotes start, and then you can apply any A, B, C, or D values to them from there.